Hey, AP Chemisters, this is Mrs. Vanderwall bringing you another edition of the Blank Wall series. Today we're going to continue on in section 15.7. We didn't get done with that in class. But before we actually get going, always remember to pause when you need to jot down questions if something doesn't make sense to you, to bring up questions in class the next day, and to follow along. So please have your calculators handy. Do the math as I do the math. I will, of course, be pausing to let you catch up, let you do the math. I'll tell you when to pause when you actually need to do the work. That's all part of what this is all about, okay? So we are talking about the acidity and basicity of salts, and we said that we had to look at each part, the cation and the anion of the salt, to determine whether or not this entire salt is going to be an acid, base, or neutral. So if we look at the salt, here's ammonium. We know that its conjugate base is ammonia, which is a weak base. How do I know that? I see it right here. What about the chloride ion? The chloride ion's its conjugate acid is HCl. And please get to know this. If the conjugate acid is a strong acid, then the chloride ion is neutral. It is not going to act like a base. It is not going to accept the H plus and create that HCl acid, the strong acid. We know a strong acid will 100% dissociate, so none of that strong acid will come back. So this chloride ion will do nothing in the acid solution. So it is neutral. The only thing that's going to contribute to the acidity or the basicity of this salt is now going to be the ammonium. So let's check this out. So here we have the equation. What will ammonium do in water? We know chloride does nothing, but what will ammonium do? Well, can it act like a base? Can it accept? Can it gain an H plus? The answer is no. We talked about in the class. There's no place for the hydrogen to attach itself to the nitrogen. So it's not going to be a base. It's only going to be an acid. So what do acids do? They lose. They donate. So take the H4 plus, make it NH3, and the water will accept it. So here's my 0.1 molar minus X plus X plus X. So here's my ice table. Now we have a little problem here because they gave me the Kb for ammonia. Do I need the Kb? The answer is no. Look at this. This is an acid. This is an acid in solution. This is an acidic ion in solution. I don't want the Kb, I want the Ka. So fortunately for you, you know how to do this. Okay, so Kw is 1 times 10 to the negative 14th. Again, we're assuming is at 25 degrees Celsius. Kb is what they just gave me. And so here is my Ka value. So now, please don't be lazy. Don't be lazy. You need to go ahead and figure out what the Ka value is. Write everything out. Write everything out and don't be lazy. Okay, so now what? Plug in your values and solve. Oh, by the way, that's what this is. And solve for X. Now, what is that X equal to? That X is equal to your hydronium concentration. Because that is your hydronium concentration, can you solve for the pH? Isn't that what they're asking for? How do you find pH from this? Go ahead and do that. Hopefully you got 5.13. Okay, now this next one is a very interesting problem. Okay, we had talked about earlier how the highly charged metallic ions can act as acids. So what's the first thing that's going to happen? The first thing that asks is, that works here, I don't know what that was all about, is that you have the aluminum with a +3 charge is going to attract some waters to it. This highly positive ion is going to attract the partially negative section of the water, the oxygen end of water to it, and the 6 waters are going to surround itself around the aluminum ion. And so that's what this is. Now, what will this do? Do you remember what we said in our notes a few pages back? That this ion here now has some hydrogens to donate. So it's going to act as an acid. So here is this ion, put it in water, it is going to donate an H+. So what did I have to do? I have to break up one of these waters here. So notice I have 6 here, I have 5 here. Break up one of the waters and donate that H+ to the H or to the water to get H2O plus here. So notice what I have left here is OH with a +2 charge. The whole charge of this aluminum ion was +3. So if it loses an H plus, the entire charge of this whole complex ion is now +2. Do you remember what I said earlier, that we have to balance the charges? So this is a +3. This side also needs to be a +3. And now this becomes like any other problem. Oops, I kind of jumped the gun there. This is what I meant to pull up. So here's my initial concentrations. Because Q is 0, it's going to shift to the right. And so what do I get over here? There I go. Now look over here. Look at the K value. Remember how the last time we had to convert to the Ka because they gave us Kb? Do we need to do that this time? Think about it. Do we need to do that this time? The answer is no, because that aluminum complex ion is acting as an acid. So the Ka value is valid. I don't need to solve for a Kb value. So just go ahead and set up, and again, don't be lazy. Write out everything. Now, I hate to tell you this, but later on this Blankwell series, I do get lazy, but don't you be lazy. You write it all out, because on the test on Friday and on the AP exam, you should write out what the Ka value is actually equal to. All right, so let's plug in our values. We have x squared over 0.10 is 1.45 times 10 to the negative fifth. Hopefully you can do your math and solve for x. And what does this X represent? Look right here, that X represents the H3O concentration. And what are they asking us to solve for? They're asking us to solve for pH. So I can just automatically plug the negative log value, and I get 3.43. So that's the pH of this aluminum chloride solution. And if you recall, when we put aluminum chloride in water, we also got a acidic value. Okay, so let's look at the next one. We're working with sodium fluoride now. So once again, we need to consider, well, which ion in this salt is going to affect the pH, the acidity, the basicity of the solution. And if you look here, here's sodium. Do you remember we said in class that sodium ion, its strong base is sodium hydroxide? Will that sodium ion attract the hydroxide to it? And the answer is no, not at all. Will the sodium ion affect the acidity? Not at all. It's a neutral ion. So what about the fluoride ion? The fluoride ion, its conjugate acid is hydrofluoric acid. And as you know, it is not one of the big 6 strong acids. So we do have to be concerned about the fluoride ion. So what happens when you put the fluoride ion in water? It will go ahead and make your weak acid HF, but make your hydroxide as well. So let's go ahead and fill out your ice table. Go ahead and you do it. You don't need to watch me do it. You do it. Pause this and fill it out. Hopefully you got this, and now we need to set up our value here. What did they give us? They gave us the Ka value. What do we need? What is fluoride acting as? Fluoride is not an acid. It can't be an acid. There's no hydrogen to donate. The only thing fluoride can be is a base. And look over here. Yes, it indeed accepted, it gained that hydrogen ion from the water. So fluoride is an acid. I can't use I'm sorry, I said that wrong. Silly me. Fluoride is a base. It is not an acid. That's what I meant to say. And so I can't use Ka. I must use the Kb value, but they gave me Ka. So what is a person to do? Well, we have to solve for Kb, because that's what fluoride is. And so Kw, as you know, is 1 times 10 to the negative 14th at 25 degrees Celsius. There's the Ka value that they gave us. And if you do your math right, here is your value here when you do that. All right, so now what? Set up your equation again. Don't be lazy. What does Kb equal to? As Brent knows, products over reactants. Okay, and now what? Plug in your values. I'll just put it under here. And solve for x. So here's our x value. And now what? Well, what is x? Go back and look up here. Oh, it's hydroxide. X is hydroxide. So I can't find the pH immediately. So if I hit the negative log button, what do I get? POH. And therefore, I have to subtract from 14 and I get pH. Now, does this make sense? Always ask yourself if it makes sense, because look at the pH. What does that pH tell you? The pH tells you that it is a base. And isn't that what I've been telling you as far as the fluoride ion goes? Right here, fluoride was a base. This solution is basic, and that's what my numbers tell me. So yes, this problem makes sense. And this is the end of section 15.7, I believe. No, I'm sorry, 15.8. So we are done with this blank wall. We're going to go ahead and I'm going to do the 15.9 next. So see you shortly.